Hello everyone and welcome to Chapter 16. Our quest is at an end. One more challenge awaits you. This chapter is a case study which will attempt to provide an overview of application development, but also to examine all of the topics that we've talked over the previous 13 weeks. So what is it that we're going to be doing? This case study is for a taxi company, and by this we mean a proper taxi company, not a gig economy Uber or Lyft kind of situation. So we have a taxi company that's considering expansion, and it has taxis and also shuttles. It's trying to determine, will its expansion be profitable? So there's a little bit of simulation aspect to this. And what they're looking to be able to determine is how many vehicles they might need. Because that's going to be a capital outlay and increase their operating costs. And so, this is information that would feed back into the business side of the house. It's more than just tracing an operational aspect of the system. So here's some facts about the taxi company. These also appear in Chapter 16, and we're going to be building this out pretty much from the ground up. You will not have much to work from as we have had in previous projects. So let's take a look at the description and see what you can determine about how this taxi company operates. Okay, so for unnamed taxi company, the company operates both individual taxis, assume one passenger or family group, and shuttles, which would be multiple family groups. The taxis are used to transport an individual or a small group from one location to another. So they have a pickup and a destination, and that's it. The shuttles are used to pick up several individuals from different locations and transport them to several destinations. So if you've ever used an airport shuttle, for instance, when you're picked up at the airport, it may stop at multiple terminals to pick up passengers and then drop off passengers at different hotels. Or flipping that around, may stop and pick up passengers at different hotels and then take them to the appropriate terminals. When the company receives a call from an individual or a hotel or an entertainment venue or a tourist organization, it tries to schedule a vehicle to pick up the fare. Okay, so there are different customer bases. Now, if it has no free vehicles, it doesn't put the request into any sort of queuing system. So if all vehicles are busy, they just say, I'm sorry, all vehicles are busy, try back again later, or go with a different company. So we're not looking at a queuing system. When a vehicle arrives at a pickup location, the driver notifies the company. Dispatch, I've arrived. When a passenger is dropped off at the destination, the driver notifies the company, and that vehicle is now available again. So from those problem descriptions, we might choose to make some extensions. Because this is about dealing with a business question, we might want to keep track of times when requests are made but can't be filled, because that represents lost revenue and would be useful to determining what might be the benefit to expanding the fleet. And we might also record details of how each vehicle passes its time. So are there vehicles that are underutilized? Are there vehicles that are in operation from the start of a shift to the end of the shift? And these issues will help to assess potential profitability. What I do want to point out is that if this is an individual company that owns the vehicles, this seems like a useful set of operations to do. If this were instead an Uber or a Lyft, where we have individuals who have their own private vehicles and they choose to go on the clock and off the clock whenever they wish. This sort of tracking would be very invasive. And so just keep in mind that there are social realities that that need to be considered as technology continues to make inroads into every aspect of our lives. I'm reminded of something that happened where an individual said, well, one of the major network hubs on the East Coast is down and now I can't vacuum the floor because for some reason their robot vacuum also requires network access. These kinds of questions should be asked by people implementing technology. Do we want everything connected to the network all the time? What is the social impact of what happens when we implement this technology? So, keeping that in mind. Since we are dealing with an individual company and they can track their assets, we need to try to find some classes. So I'm going to ask you to read over the problem description in your text, maybe go back and freeze frame on those two problem descriptions and try to come up with some nouns, or look at the nouns that we have here. So pause, and when you come back, we'll continue. Okay, welcome back. So if we look for singular nouns, company, taxi, shuttle, individual, location, destination, hotel, entertainment venue, tourist organization, vehicle, fare, pickup location, driver, passenger. If you start to look at these nouns that popped up from the description, and this is going to be often the case when you're collecting information about a system that needs to be made, there are probably different words that are being used to identify the same object, the same noun in the system. It's important that you identify synonyms. Those are words that mean the same thing in terms of the description. For instance, what are some of the possible overlaps for passenger in that list of classes? How important is it to have each of the individual descriptors versus just having an umbrella descriptor that encapsulates, not in the object-oriented sense, but kind of coalesces all of those different potential origination points with a single term or a single class within our system. So as we think about collapsing these down, we come up with a list of simplified nouns and the verbs that they need to be able to perform, or in other words, the classes and their methods. At least a first pass. So the company operates taxis and receives calls and schedules a vehicle. Okay, so we have some very clear actions the company class will need to do. A vehicle picks up an individual, arrives at a pickup location, notifies the company of arrival, notifies the company of drop-off. Okay, a shuttle transports one or more passengers. A taxi transports a passenger. Here's where the language starts to get a little sticky. You could say that a taxi transports a passenger group and a shuttle transports multiple passenger groups, because it might be the case that, you know, a family is taking the shuttle or a family is taking the taxi. So there's that distinction that you need to think about. Or you could just say that a passenger is implied to indicate a grouping rather than an individual. Then the naming of the class starts to become slightly confusing if we don't indicate the multiple possibilities there, but it's one of the choices you'll make as the developer. Okay, so we had shuttle and taxi. Location, and can a location be both a pickup and a drop-off? Possibly. Passenger, and then a passenger source. Passenger source is an entity that calls the company. Okay, and you can see where from a business standpoint that might be useful as well, where if there is a particular passenger source that is giving your company a lot of business, you may look to provide discounts or further incentives to strengthen that business relationship. So being able to track, you know, where where your business is coming from is probably going to be a uh, useful thing to model. From these, you can make up your CRC cards. And if we were to look at some scenarios, here's just one possible scenario. We could follow a pickup from request to drop off. So, for example, our passenger source would need to create a passenger, request a taxi, and generate a pickup and destination. To create a passenger, it would need to use the passenger class to request a taxi. It communicates to the taxi company class. To generate pickup and destination, it needs to collaborate with the location class. And you could imagine in our hyper-connected world where that location could include, like, a Google or Apple map, GPS coordinate, and dropping a pin and some other things like that as well. Although clearly we don't need to worry about implementing that for this demonstration. Once you have gone through not just that scenario, but all the scenarios that you can conceive of that are reasonable, and at least the ones that are provided for in the textbook, you can move to designing your class interfaces. Now, remember, we don't want to worry about how, we just want to worry about what for right now. So the key word there is interface rather than class. We want to know which methods are public, which methods are private, what their return types are, what they're called, what parameters they need. And those will all be suggested by the walkthrough that you do with your CRC cards. When we determine collaborators, it's going to raise questions for us. Is it something that we have to give information to the other class so that it can use it within its constructor, or is it going to be a method we call on the other class? So for instance, with a passenger, we might create a new passenger object or passenger source object with the taxi company being passed in so the source knows which company it's dealing with. Or we could have the taxi company have a method that says requesting the pickup, and the passenger object gets passed into it. So depending on where the construction takes place, it will allow certain tasks in the code to be accomplished more easily. So for instance, some things, such as the amount of vehicles the taxi company has, doesn't need any other object in order to be created. That is just a property of the taxi company. So you could have an array list of vehicles, or you might want to be a little bit more constrained in that the array list would be able to grow without bounds, but you would need to maybe cap a maximum bound on that, because where would you park infinite vehicles? And so, you could craft some solutions to model what is a reasonable fleet object, which would go, sort of next step beyond this to ensure that you could make sure that the number of vehicles is reasonable given some other real-world constraints. Or you could just be careful in your simulation not to create 2,000 vehicles or 20,000 vehicles in the fleet. Other objects that are not part of the properties or the institution of what that object needs to do will have to be passed as collaborators. So just remember that moving objects from moving references from objects to one another is an important part of designing your system. Once you've determined all of your interfaces, now you can start to flesh out the outline. Which is to say, instead of just thinking about what you would do with CRC cards, you can actually begin to write stub code, which is code that doesn't do anything apart from calling the interface, calling the class with dummy objects or hard-coded values. And you're going to walk through that and say, oh, wait a second, I forgot that I also need this piece of information. I need to pass another parameter. And so you'll modify your interfaces. In fact, you should expect to have to correct the design. You're not going to get it right the first time, and that's perfectly okay. But as you're walking through the interfaces, you can also start to lay down your unit tests. How am I going to test that this object does what it's supposed to do? And this will help you through test-driven development to make sure that you're not introducing errors as things occur in the development. You'll be like, oh, well, I already know that there are certain things that I've done and tested, so let me just run the tests, rather than like, I think I made a change that might have introduced an error, but I don't know. So this is a kind of a place where looking at the objects up front and testing the flow of the expected behavior gives us some confidence in our later implementation. It won't eliminate all bugs, but it should cut down on the number of bugs that get introduced. By doing things this way, we are embracing iterative development, sort of that spiral where we have an idea, we design a solution, we implement a simple version of the solution, we test that, we learn from that, leading to more redesign, which expands the development. And part of that is in that spiral, we need to have that period of testing. We want a regression test to make sure that we haven't introduced any new bugs. We want to spot those errors and fix them early. We can also go back and say, wait a second, were our initial assumptions correct about how we should implement this? Before things get too enmeshed and it becomes costly to make changes because it will end up rippling through multiple classes, let's see if we can revisit those earlier design decisions and confirm that they made sense. Here's the important thing. Finding an error is not a failure. Finding an error at this point is a huge success because it's saving you development time and maintenance. It's just the amount of money in a commercial system that this will save over time is huge. So you want to be happy if your design was verified as being good, but you want to be even happier if you've discovered a bug and it's like, oh, wait a second, I forgot about this, and make the change early. Okay, so here's what I need you to keep in mind. When you're designing software, when you're the systems analyst, you're going to be working from a specification. You might be responsible for helping to develop that specification. You won't necessarily be given a system to work with, or you may be given a system to work with a legacy system that needs to be completely rewritten and scrapped. Or you may be given a legacy system that parts of need to be updated and parts of still need to function. Old software, I won't say never dies, but there is a cost to doing hard cutovers. And so you're going to get different kinds of challenges presented to you when you need to design a system. Part of what that entails is doing very careful analysis. but not being fearful in that analysis. You're gonna get it wrong, but you're going to loop back around. You're going to analyze, test your understanding, do a quick prototype, show it to your client, have the client say to you, hey, wait a second, that doesn't capture this, I forgot to mention this, or you didn't understand what this term meant. And you'll have this collaboration that happens, which will help you to clarify the specifications. As you go through the spiral and you get more clarity in the specifications, your design will become more thorough and it will start to hone in. Be careful and guard against the idea that your code has to be flexible enough to solve every problem. What I mean is solve every problem ever in this problem domain. You're not building a framework, you're building a solution. Focus on building the solution. If at some point you find that you're in a position where you're building a framework, then shift to more general kinds of code. But don't solve the problem that doesn't exist. Solve the problem that's in front of you. Implement your solution and test it, and don't just test it at the end, test it as you're building it. If you can get test data from your client, or, so start with just bogus test data that shows that things will work. As soon as you can get a subset of anonymized test data or something that you can use to verify actual flow of data through your system, try to implement that by reading files or having a network feed or something. But here's what I want you to keep in mind. You're still not going to get it right, so you're going to review, make sure you look at your logs, write out system errors, catch exceptions, do everything you need to do. Review what happens, revise your expectations, perform the analysis, continue on the spiral, learn. And nobody's perfect. You won't develop it right the first time, but if you keep at it, you will ship a system that meets the goals for the contract or the business needs. And it becomes a system that goes from under development to live. And that's something that you can feel good about. I just want to say thank you for going through this class with me. This is the first time I've done an online course. I think that this course lends itself in some ways to online implementation. In others, it's not as interactive as it would be in the classroom. But you've made it this far. You've made it to the end, and you should feel proud about that. So thank you for taking this journey. I wish you well and hope to see you in one of my classes again in the near future.